Hi kids, I'm back, and it's Planet Week. So we're going to talk about all the planets. There's a whole bunch of activities I normally do with this stuff. I think I have about 30 different posters on planets, including the ones on the wall in the classroom, which we're not going to get to take a look at. I've got a really nice one about Mars. I've got a lot of really cool posters about Jupiter's moons and the moon and all this cool stuff. We're not going to get to see any of that. It's all in the classroom. But I want to talk about the planets and then all the stuff that goes with the planets, asteroids, meteors, comets. What's the difference between a meteor, meteorite, meteoroid, and all of that? And let's see, what else? The sun could take us an entire week all by itself. The sun is really interesting. If you're just looking at the surface of the sun, there's just all this cool stuff going on. So I'm going to start with planets, I guess, and that means Mercury, the god of messages, Hermes, Mercury. If you look up Greek and Roman mythology, he had little winged booties on his feet. You remember booties, right? Or Boetes, that's the constellation. Well, these are different. There's a little thing you put on your feet, booties. And so Mercury is really small, just a little bit bigger than the moon, really hot during the day, really cold at night, 800 degrees during the day, minus 130 at night, and the temperature change is just because there's not enough atmosphere to stop the heat from the sun from cooking the surface. But then at night, there's no sun, so it just freezes, and you get 800 degrees during the day and minus 130 at night, but not the hottest planet in the solar system, because Venus is hotter than that, mainly because of how thick its atmosphere. So Mercury's thin atmosphere makes it really hot and really cold. Venus's really thick atmosphere makes it really hot and really hot, but we'll get to that in a minute. Mercury, no moons, closest to the sun. Anything that comes into orbit around Mercury gets pulled into the sun, and so it doesn't have a chance to catch a moon and capture an object. And so there's a few ways to get a moon. One, something hits you really hard and a bunch of stuff blasts off into space and that forms a moon. Two, something tries to go by and gets caught by your gravity and you catch it, that's a moon. How else do you make moons? There's probably another way to make a moon, but I don't know it right off the top of my head. Mercury, no moons. Lots and lots of craters because there's no water for erosion, there's no wind, well, there's no erosional wind. There's not enough wind to make the ground change shape. Mercury's just got covered in craters, just like the moon. It doesn't have enough fluid motion over the surface to make those craters go away. So it's always going to have craters, just like our moon does. Let's see, what else about Mercury? It's got an 88-day long year. It's got really long day. I don't remember how long. And it's real close to the sun, so it's really hot. Planet number 2, Venus, hotter than Mercury. It's collecting heat from the sun, never lets any of it go. It has a massively heavy atmosphere made of ammonia and carbon dioxide. There's nitrogen also, just like the Earth. So Venus is so much like the Earth, almost the same size, almost the same gravity, almost the same length of a day, slightly shorter year because it's closer to the sun, 224-day year. But that's just because it's closer to the sun. It doesn't have as far to go around one time. But Venus, and it's got tens of thousands of volcanoes. It's got tons of plate tectonics. It's got rifting. It's got volcanism. It's got all kinds of stuff going on in its crust with magma flows and heat coming out from the core. Excuse me. And so that's snot, right? That's pecan pollen, and just, really fun week for me. My truck, the brand new one, the black one, it's now yellow. So anyway, Venus is just tens of thousands of volcanoes. Earth has thousands of volcanoes. Venus has 10 times as many or more. The atmosphere, again, 10 times as heavy as the Earth's atmosphere. Lots of carbon dioxide. If you stood in Venus's atmosphere, 1, you would suffocate. But 2, you would be crushed into a ball about the size of a grapefruit. just the weight of the atmosphere would squash you that much. It's like being a mile under the ocean. It is a really, really, really heavy atmosphere, mostly carbon dioxide. In fact, the carbon dioxide on Venus outweighs the carbon dioxide on Earth by 100 times, I think. I'll have to go look that one up. You can look that one up too if you really want to. It's some pretty exciting stuff, looking up the weight of carbon dioxide on Venus. So anyway, Venus, Roman goddess of love, also known as the evening star. Venus will come up over the horizon in the evening, and right now, like this week, last week, this week, it's Venus comes up over the horizon just as the sun is going down, and you get this really bright looking star popping up, and it's Venus, it's not a star. It's called the evening star because it's brightest in the evening. Venus has a really high albedo, which means it reflects light a lot. And so when the sun is just going down and Venus is just coming up, you get this really bright looking dot in the sky. And you can actually take a picture of it with your phone and see it's bigger than a normal star, and it's a planet. And so Venus that has a high reflectivity. It's called albedo. Reflectivity of a surface is called albedo. The moon has a high albedo, and the Earth's north and south pole with all that ice and snow has a high albedo. But the rest of the Earth does not have a high albedo because the water absorbs light really well. And that's why the Earth has life on it, is because that water absorbs energy so well and still stays liquid. But Venus could have had water. We don't know. It's not on the ground right now. There's so much lava, so much magma flowing, so much heat that any water vapor that is there is going to be in the atmosphere as a gas, not a liquid on the surface. So Venus is not going to have liquid water. If you could get an atmosphere like the Earth's on Venus, you could probably have liquid water there. It's probably in the Goldilocks zone. But Goldilocks zone being the right distance from the star to have liquid water. That's the for life to exist. That's the key, is a liquid to live in, a liquid to form life in. So Venus is the same gravity as the Earth almost. It's a little bit less, but its mass is a little bit less. Its diameter is a little bit less. No moons, and very, 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 very heavy, thick atmosphere of carbon dioxide. Then you have the Earth. We spent an entire semester on the Earth. I've spent my whole life on the Earth, but that's just me. We spent a whole semester talking about the Earth and the Earth's atmosphere, and this is making me crazy. I'm gonna have to fix this. This has to be adjusted. All right, that's not gonna work either. No. A little bit better. So we spent most of the year talking about the Earth, so we're gonna skip that one. So we go Mercury, Venus, Earth, Mars. Yes, I want you to know them in order: Mercury, Venus, Earth, Mars. The terrestrial planets, the rocky planets, the planets made of rocks. So when the solar system formed, the sun ignites, fusion begins, hydrogen starts turning into helium, and that creates a radiation pressure called the solar wind. And the solar wind pushes all of the hydrogen that didn't fall into the sun out away from the sun. And so the only thing left here within 100 million miles of the sun, the only thing left over was mostly rocks. So you get a lot of silicate, get a lot of iron, and then all the other heavy elements that are on the periodic table. We do have some hydrogen, we do have some helium, we had water vapor. A lot of that was trapped in the rocks and couldn't get blown away. And so Venus's atmosphere is kept on Venus by the magnetic field around Venus, which is not as strong as the Earth's, but it's a strong magnetic field protecting the atmosphere from the sun's radiation pressure called solar wind. The Earth has a magnetic field keeping the atmosphere from being blown away by the solar wind, but Mars does not. Mars has a core of iron. It may or may not be liquid, but it's not rotating, it's not spinning in there. And so since you don't have the solid core spinning this way and the liquid core spinning all kinds of ways, you don't get the magnetic field. And so Mars' magnetic field went away, and so its atmosphere was blasted off by the sun. And so we had Mercury, no moons; Venus, no moons; Earth, one moon that's way too big for the Earth to actually hold on to, but it stayed. There's special circumstances. Mars, two moons, and you can tell that they're not really very big by their shape. They're big asteroids is what they're lumpy rocky shapes. They're not round like the moon of the Earth is. And so you got 2 moons around Mars. No atmosphere worth mentioning on Mars. It's mostly carbon dioxide and dust, and it's iron oxide dust. It's a bunch of orange dust. The Martian surface is covered in this rusty stuff. The Earth looked like that for a while, and so Mars and Earth evolved kind of together. It was lava on the surface, magma all over the surface, and then the crust formed for Earth and Mars. The crust formed, and then the volcano started venting gases, and those gases were carbon dioxide, ammonia, methane, all kinds of nasty stuff that early life wanted to live in because early life needed those gases to survive. And then water vapor, and the water vapor started falling out of the sky. Mars had water. We've found frozen water on Mars. It had liquid water, probably, most likely. There are definitely water channels or liquid fluid channels on Mars. Probably water, because there's not going to be liquid methane on Mars. It's just not cold enough. And so I didn't mention Venus's temperatures. Venus's temperatures is 1,000 degrees during the day and 400 degrees at night. So at night on Venus, you can cook a turkey by putting it on a rock for 5 or 6 hours. And you can melt lead right next to that. It's like cook a turkey and melt some lead at the same time. It's really hot on Venus. Anyway, Mars, cold at night, hot during the day. We're talking 200 degrees, 300 degrees during the day, negative 200 degrees at night. No atmosphere to keep that heat in. If the core were still rotating properly inside there, there would be a magnetic field to provide a proper atmosphere to keep the atmosphere from getting blown away, but it got blown away. Mars evolved volcanoes just like Earth did. Mars evolved rifting like Earth did. Mars has the biggest volcano in the solar system. It is Olympus Mons. It is 20 times wider than the biggest mountain on Earth and 5 times taller. Biggest mountain on Earth is not Everest. Everest is the highest mountain on Earth, but it is slightly smaller than the Hawaiian Islands, Mauna Loa, Kilauea, etc. The Hawaiian Islands, the big island, is the biggest mountain on Earth, and it goes from the bottom of the ocean up 30,000 feet. Everest, 29,000 feet, slightly smaller. But Mount Everest is 10 times narrower than the Hawaiian Islands. The Hawaiian Islands are a very, very wide shield volcano mountain. Shield volcanoes are very wide and tall. And Everest is just tall. It's not wide. It is a folded mountain range mountain. And so we talked all about the geology of all that. But so Mauna Loa, the main island, Hawaii, big volcanic mountain. But Olympus Mons on Mars, 20 times wider, 5 times taller. You could fit Mount Everest in the crater. I mean, it's a massive structure. Second big feature on Mars is a canyon, like the Grand Canyon, but 10 times longer and 5 times deeper. So everything on Mars, as far as plate tectonics goes, just happened on a bigger scale than on the Earth. And Mars is smaller than the Earth. There's less gravity, so you can get these bigger structures with less gravity. About 40% the gravity of the Earth, about 1/10 the mass of the Earth, about 1/10 the size of the Earth. And so you got Mars is smaller, but no atmosphere, no magnetic field to preserve the atmosphere, and all the water froze and got buried under this iron oxide dust. And so there you have your Mercury, your Venus, Earth, Mars. And then the asteroid belt. The asteroid belt could have formed a planet. It has enough stuff. But the sun is fighting for that material, trying to pull it in, and Jupiter is fighting for that material, trying to pull it out. So it's kind of stuck there. It can't form a planet because there's too much gravitational force in both directions for all of that material to come together in that orbit and form a sphere and make another planet. So not another planet. We do have a large asteroid there named Ceres, C-E-R-E-S. Ceres is the biggest asteroid in the asteroid belt between Mars and Jupiter. So Mercury, Venus, Earth, Mars, asteroid belt, then Jupiter. And so I'm going to stop that right there. We'll talk about gas giants later.